Hello, this is 6-5. Solving absolute value equations. These are some of my favorite problems. I just think they're so much fun. A couple ways you could solve them. First off, you might be saying, well, let's just graph them. Take this and graph that as an absolute value function. So it's f of x equals 2 x minus 3 plus 1. You can actually put that into your calculator at y1. I would do that. So by hand we can do it this way. We know that it's going to the right 3, up 1. So we go right 3, up 1. It's got a stretch of 2. So we go up 2. I'm trying to be real accurate, so that's why I'm extending these points out a little bit. Now on your y2, you could graph f of x equals 5. Hope that makes sense because it's just a straight line. It's just this side of the equation. So at 5, just a straight line. And you can see you have two solutions. Okay? We have 1, 5, and we have 5, 5. So x equaling 1 is one solution, and x equaling 5 is the other solution. Now let's look at another way that we could solve that. We could have done it algebraically. I like the algebraic way. If you're in my class learning how to do solving equations, you know I have you draw the line down at the equals, circle the creepy dude. Yeah, you want to hear a really creepy thing. Your creepy dude's inside of a closet. Do not open that closet door until you have everything outside cleared away. So you go up the PIMDAs. I apologize if you missed my Algebra 1-1 class. Have me solve just a regular equation. It's quite a story, okay? And then we get into this one. It's just fun, creepy stories that just keep us engaged in the math. So, finding our creepy dude, we go up the PIMDAs. We start outside the closet doors and add, subtract. What's being added or subtracted on this side of the teeter-totter? It's a +1, so we do the opposite, get rid of it. That wipes out. We have 2. Leave the closet doors alone. He's inside there. You don't want to open it up and get him freaked out. So we have 2 absolute value equals 4. Now get rid of this. It's being multiplied, so we divide. And we end up with inside the closet doors equals 2. Now we need to go to something. We need to talk about what absolute value means. If you're saying it's a distance from 0, you are correct. The distance, remember, can go to the left or to the right. So we're saying the distance is 2 units. But that could be 2 positive or 2 negative, because it could go either direction. Now we can open up the closet doors. X minus 3 equals 2, or x minus 3 equals negative 2. We add 3 to each side to get the x alone. And we find x equals 1. That's one solution. Or we add 3 to each side, and we find that x equals 5. Isn't that exactly what we found here? 1 and 5. So you can solve it either way. I'd like to see you solve it both ways. Okay, I want you confident at both. So here's a real world problem we need to graph probably. Harry's going to drive directly to a point 4 miles away. Then he reverses back to school. He drives at a ½ mile per minute. Write and graph a model that gives the distance in miles from the school as a function of time in minutes. Use the graph to find the time when Harry is 2 miles from the school. So, a couple things here. We usually always put time on our x-axis. And we know that the distance is a function of time, so that makes sense. Because this is our f of x, function of time. Okay, now it said to graph it in minutes. So let's go 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now it says that he drives half a mile per minute. So let's make that 1 mile. So he'll be that far in 1 minute, half a mile a minute. He'll be a full mile in 2 minutes. He's going to go, how far? 4 miles away. Ooh, we're not going to make it in that amount. Let's shrink this down. Let's go 1 here, 2 here, 3 here, 4 there. Okay, so 1 mile in a minute. I'm sorry, he goes half a mile a minute. So half a mile, there's 1 and 2. Did I help myself at all? No, I don't think I did. So here's 1 mile, 2, 3, 4. Okay, it goes a half mile in a minute, so there's a full mile in 2 minutes, 2 miles in 4 minutes. It takes him 8 minutes. I see where I need to shrink. I am so sorry, you guys. So there's my time. I need to shrink this down. So we're going to go, that's 2, 4, 6, 8, 10, 12. It's going to be every single square is a minute. Takes him 2 minutes to make a mile because he's going a half a mile a minute. So there's our slope. Now it says that he goes out here. Goes out here 4 miles. So at 4 miles it says he turns around and starts coming back. And I honestly just graph it and play with it as I go, as you can see. Now it says, use the graph to find the time when he's 2 miles from the school. There's the 2. And there's your pathway that he takes. So at 4 minutes, he's 2 miles from the school, or at 12 minutes, he's 2 miles from the school. The only way to really do that one is to either set it up in the graph or to set it up with our slope here. It's a half a mile a minute. So see how we have them, and it's a reflection. X minus, let's find our vertex. It's at 8, 4, so x minus 8 plus 4 equals, and we'd set it equal to that 2. And we could also solve it that way. So it's easiest to me to graph that kind just so you can get the equation if nothing else, but it might not hurt to check it by the equation. Okay, we'll see you in class. You're going to do something like that.